about one is that just quickly cover our normal USB lamp. And after that, I'm going to talk about how you could go about making a much brighter version of a USB lamp should you wish to. Okay, so like I said earlier, I don't know if you caught it or not, but we're going to use a little plug-in USB adapter just to get power. So it's one of these things here. Obviously, you could use the USB port of a computer, but because of the setup here today, we're going to use one of these instead. So what I'm going to talk about first, if we can just zoom down onto this this top. Yeah. Okay. We're going to cover just this. Basically, this is our normal USB lamp. So it takes power from this USB lead here. Now you could use any USB lead, but if you cut into a normal USB lead, what you'd find inside would be 4 wires. 2 of those are for power, and you'd have to mess around trying to find out which ones they were, and 2 of them would be for data. So if you were connecting between 2 devices, that's how the data's transferred. We've had a lead made that only has the power cables in, so you haven't got the 2 data cables. There's no confusion there, and we've conveniently made them red and black, so it's obvious which is the positive and which is the negative, and it takes those connections off this connector here. So this lead provides us with a 5-volt power source. That power source in this example then goes off to our little project board. On this project board we've got a switch. This is a colour changing one, so we've got a colour changing LED and a resistor. The colour changing LED doesn't actually need a resistor, so in this instance there's a resistor there, it's actually a 0 ohm link, so it's in effect just a wire. We do a white version of this lamp, so instead of being a colour change LED, it uses a high brightness white LED and a resistor, but it's pretty much the same principle. So we could turn this on, and here we are. We've got a little, I've seen here, but it's a colour change LED that cycles through the rainbow. We showed you earlier this LED and some other projects we've got. So that's a neat little USB lamp. But even with the white LED, they're not mega bright. You wouldn't be able to use them to light a room or read, really. They're more for sort of accent or mood lighting. But one of the things we've added to the range a little while back now is a high brightness LED star. So that's this device you can see here. So we do these in 2 versions. We do a 1 watt and a 3 watt version. Now realistically you can only really use the 1 watt with a USB port. These LEDs themselves are so bright they actually get quite hot. Even you may always generally assume that LED lighting is cool, and it is in comparison to a traditional kind of incandescent light bulb. But these high output LEDs do actually still get warm. So these LEDs become a supply pre-mounted onto these. You can see it's an aluminium PCB for heat dissipation to keep the LED cool and stop it becoming damaged. So it's quite a convenient package though. So on the connection points we've got 2 negative connections, so you can go on to another LED should you wish, and then positive connections at the top. So they're where you would solder to. Now I must warn you a little bit with this. Because it's an aluminium backed PCB, you're going to need to, if you've got a variable temperature soldering iron, you're going to have to whack it up onto a high setting. If you've got sort of an 18 watt soldering iron, you might just about scrape it. You might need a high power soldering iron to get enough heat into the PCB. Because the PCB is dissipating the heat away, it's actually harder with a soldering iron to get it warm enough. It's obviously doable. I've done it here, but it's not as easy as soldering to a normal component. But it's sort of part and parcel of using these style LEDs. So again, we've got the same USB power lead we've got here, and we've got a special high power resistor. Now if it's a 1 watt LED, you can't use your typical 1/4 watt resistor because you destroy the resistor. It's not a high enough power rating. So we do actually sell higher power resistors for use in this application. So what I've done, you probably can see this here, off our website there's a tutorial showing you, talking about the LED stars and things you can do with them. So and one of those is using them with a power supply. Another application is, which is the one we're using here, is using an LED star with a USB power lead to create a high power lamp. So before we turn it all on, you can sort of see what's going on. I've soldered the negative to the negative connection on the LED star. I've connected the resistor, soldered the resistor to the positive connection from the USB lead, but I've not soldered it onto here at the moment. Now, you normally would do. The reason I haven't is because I'm going to, in effect, use this as a switch so I can show you turn it on and off. So let's just plug this in. And I'm not sure how bright this is going to seem on the camera. You can see this one, yeah, it's pretty good. So yeah, I mean, these are where we're stood here. Yeah, it's very it's hard to look at this LED. It's that bright. So yeah, I can imagine really that you can make quite a nice lamp out of this or something. It would be bright enough for many applications. So these are really, really good. So they're not that expensive. So if you're looking to make something a bit more powerful than your sort of typical USB power USB lamp, but these LED stars are a good option. Obviously, you could choose to put a power switch in series, or you could use this lead, then go off and mount the things in different positions within your application. But it's a nice and simple way of making a very high brightness white LED lamp. Okay.